Good Wednesday morning. This was a planned absence. I just didn't want to tell you. I'm gonna be honest. I was so afraid that as I was telling you that you guys would start crying because I know how much you guys miss me when I'm not here. So I just decided not to tell you. But no, I had to run to Athens, Alabama this morning. Anyways, this was a planned absence. Really easy day, but you got to have your calculator. We're going to go over last night's homework, and then I'm going to teach you guys today's lesson. And today's lessons is it's all about the calculator. So again, if you didn't grab one on your way in, go grab one right now. But you definitely need it today. So let's knock this homework out. A local candy store has found that kids prefer certain colors of candy regardless of the taste. For kids aged 5 to 8, the following data was collected. What is the population proportion of the most preferred candy? Okay, so most preferred, that means the one that you see the absolute most, and that, of course, is red. So, population proportion, I told you guys yesterday, that's when you write a fraction. You're going to put the one that's specifically identified, 89, over the total. So you're going to tally all these up, and again, you were supposed to do that last night, and you should have gotten 196. Now, we always turn population proportions into fractions, then fractions into decimals, and then decimals into percents. So when they ask me about the population proportion, I'm looking for either a fraction or a percent. So here, 89 divided by 196 is 0.45, and then if you didn't round, you would round the third decimal to 4, so that would be approximately 45% who prefer red. Okay, very simple. The next one, again, you can read the whole thing on your own. Let's scroll on down to where it says the estimated population mean. Now, we talked about mean as being the average. So I would encourage you guys to go into here, and I'm going to show you guys. We're going to go to Stat. We're going to go to Edit. I'd already cleared my calculator, which I think is always a good thing to do. And we just start entering our values into list 1. We got 4, 3, 5, 12, 14, and 16. And then, of course, you're just going to enter all those values, and you're going to run the data. So we go back to Stat. This time we go over to Calculate, and we run a 1-var stats. We scroll down here to Calculate, and population mean we base on the sample mean. And the sample mean, of course, being 9. So our X bar is 9. But we haven't really answered the question yet, okay? The question actually doesn't say, hey, yeah, it does. It says, what is it? Well, it's 9 hours. 9 hours per week. Okay? Moving on to number 3. Which one is the correct representation of a proportion? So remember what I said just a second ago when we did this problem? It's either going to be a fraction or a percent. So let's look at this. The average amount of hours that 18 to 25-year-old males spend playing video games. The average amount. Remember, average is mean, not proportion. B, a study that found its poll had a margin of error as 5%. Again, this says margin of error. That's not proportion. C, a research firm that found that 85% of all employees spend an hour eating lunch. There is a percent. 85% eat lunch. So it's got to be C. And let's check out D. A study claims that people who stare at a computer screen for too long have an increased chance of developing eye fatigue. Here you don't really see something that could be developed into a fraction or a percent, so C is our only answer. 4. A company specializing in building robots can clean your house has found that the average time, okay, this is our mean, okay, and it takes about 2 hours per week, okay, so 2 hours per week. If the margin of error is 0.018, between what two values are you confident the population mean would fall? So like we said yesterday, when we do margin of error, we're going to subtract and add our margin of error to our average. So if you do that, 2 minus 0.018 is 1.982. And then we're going to add 0.018 to 2, so that's 2.018. All right, let's keep on moving to the back side. That one was pretty easy. This one is telling us that the margin of error is 4.79. Y'all see that? Margin of error is 4.79 million. So it asks, between what two values are you confident the population mean would fall? So again, I have to, in this case, different than the last problem, we actually have to find the mean. So here we go. I'm going to go back to stat edit, and I'm just going to cover up. Okay, you could delete, but I'm going to cover up. So 6.7, 11.3, 38.5, 100.4, and this is a crazy range, 76.3, and it just so happens we have the exact same number of numbers, so here we have them all listed. I'm going to go back to stat, calculate, we're going to run a one variable statistics, and our X bar here is 41 point, and since the value it gives us is 2 decimals, 4.79, I'm personally going to go ahead and round to 2 decimals, so 41.53. So let's go back out to the paper, because now you're going to get your calculator and you're going to take this margin of error and you're going to add it and subtract it to your X bar. So here we go. 41.53 is 36.74. And then we're going to add it. So 41.53 plus 4.79 is 46.32. All right? Number 6. A total of 50 boats participate in a race. You decide to figure out what average finishing time. Remember, average means we're dealing with mean, the mean. But everything happens fast. If you can get a sample of 5 boats written down, then let's find the average finishing times. So what's my population mean? So again, just like the last problem, we're finding an average. So I'm going to go back to my calculator. I'm going to do another cover up. So I'm going to do 63, enter, 62, enter, 67, enter, 69, enter, and 73. Now don't forget, here we had an extra one, so I'm just going to delete that one value. Never delete your entire list. Never come up here to L1 or L2 and delete it. Okay, you can clear it, but don't delete it. So here I have my values. Let's run our average. So our X bar here is 66.8. 66.8 is our average. What are we talking about here? Well, it was seconds, right? It was seconds. So 66.8 seconds. Okay, moving along, number 7. Which of the following is most like a proportion of a sample? Again, we're looking for a fraction or we're looking for a percentage. So look at A. 95 out of 100. That's 95 out of 100. That's definitely a fraction. So that counts. Look at B. 95%. That's a decimal, or that's a percent. Definitely counts. C. 95 in 100. Again, that's another fraction. So sure enough, all of the above. So we can erase all but D. D is our answer. Okay? All right, and then of course, number 8, which of the following best represents a sample mean? That's an average. So would an average length of a bridge in America being 500 feet long? Would that be it? Well, yeah. It says the word average there. It has to be. But look at B. It's found that on average, 53% of voters. Now, I know it says the word average here, but it's saying that 53% of voters are Republican. That is a proportion. Okay, you got to look at that last part. That's a proportion. It's not a mean. C, TV shows average about 22 minutes for every 30 minutes. That's 22 out of 30. That's a fraction. That's a proportion. So my answer here is just A. Just A. Okay? And then the last one, I Love Pie Pizza, plays surveys. That's supposed to be surveys. No, it's right. A random sample of customers to determine their favorite pizza. Now, if you keep looking, you can see all the data. It wants to know the population proportion of hot and spicy pizza. So hot and spicy pizza is right there. It's 26. So that's my top number, 26, out of the total. So you're going to accumulate those, and that total is 124. So we're going to divide that. If you divide that, that's approximately 0.209. So we're going to say it's about 21%. About 21% prefer hot and spicy pizza. So there you have it. Pretty easy assignment. Check that. Make sure you have it all done. And if you have any questions about it, hold on till tomorrow. Okay? So now we're going to move along to what we're doing today. And like I told you guys, yesterday I said that maybe it was the easiest lesson of this whole packet, but I actually think maybe I'm lying. I think what we're going to do today is going to be the easiest. What we're going to do Thursday and Friday, depending on how that time goes, where you guys are going to the career fair. So we're either tomorrow or Friday going to do the other part of this note sheet that you're going to go by, and it's probably the hardest one. But today, so easy. Okay, so here's what we're talking about. We're talking about measures of central tendency. Now, you've heard most of these words before, okay? Central tendency means it's a value that describes the center or the middle of the data. And you've learned these words before. So really what today is going to be is for me to show you guys with the calculator how to find all of them. Now, we already talked about the mean. The mean, of course, when you talk about population mean, is mu, but we're going to focus on X bar, and that is simply defined as the average. It's the average. The mean is the average. The median is the middle value. So it's your middle value, but there's one key component to finding that middle value. You have to put the numbers in order. So it's the middle value when the numbers are in order. And the only one that your calculator won't find is the mode, and that is your most often occurring. Your most often occurring. So literally you look at the one that occurs most often. It's the most, let's just say it's the most repeated value. It's the most repeated value. So listen, if every one of your numbers are only used once, you have no mode, okay? Nothing is repeated. So what I like to do first, and we actually don't even have to do putting these numbers in order, because I'm going to show you guys today how to use your calculator. We already know how to do it for mean, but I'm going to show you where to find median as well. So the only one we have to really think about or look at is the mode. So I want you to look at this value. Here's kind of what I do. 58, is it repeated? Yes. So we have a 58, it's repeated twice. 53, is it? No. 59, is it? No. 51, is it? Absolutes, repeated twice. 46 is not, 35 is not, 60 is not. So this actually has two modes, and it has literally two modes. It's 51 and 58. You don't like average the modes, you just include both of them, okay? So that's one of the methods of finding the center of your data. Look at number 2. Again, I'm going to do the same thing. Is 21 repeated? No. Is 10? No. 27? No. Is 24? Yeah, there's 24. There's 24. There's 24. It's actually 3 times. Is 15? Yeah, you got 15 here. You got 15 there. Is 7? No. Is 19? No. Is 31? No. Is 11? No. So, in this case, does it have two modes? No, it doesn't, because 24 is the most repeated. 24 is our mode. Does that make sense? It's very simple. So let me show you guys the rest, okay? Let's go back to our calculator, and let's go ahead and do what we should always do. Second plus 712. We're going to go back to stat edit, just like we did yesterday, and we're going to enter these values. So here we go, 58. I don't care that it's horizontal on my list, on my paper. We're going down L1. So we got 53, we got 59, we got 51. We enter every one of these values. You don't leave anything out. 46, 35, 51, 58, and 60. So we got every one of these numbers in here. I like to double check them. I like to count them, make sure I didn't miss anything. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Got them all? So here we go. We go back to stat, but this time we scroll over to calculate and we do the same thing, a 1 var stats. We already talked about how this X bar is your mean. So my mean is 52 point, and we'll go ahead and round to 1 decimal, 52.3. 52.3 is my mean. But I want you guys to now scroll on down, and your calculator will find a lot of other things. We'll talk about some of the other ones here in a minute. But MED, that is your median. So it takes the liberty to put your numbers in order and find the middle one. And in this case, that middle number is 53. See how easy this is? Calculator does it for me. So let's do another one. Let's go back to stat, edit. It looks like I have more numbers, so I'm just going to cover up. So 21, 10, 27. I know I'm a hypocrite. I think I try to tell you guys always reset, but I'm just going to cover them up. 24, 15. We got 7, 19. We've got 24, 31, 15, 11, and 24. I don't have to delete anything. I covered them all up. Again, I like to double check to make sure I have all of them. So double check, make sure you got all of them. And then we're ready to go to stat, scroll over to calculate, and run a 1 variable statistics like we said. X bar, that's my mean. So 19. And then we scroll on down and we find MED, which is 20. So my median is 20. So here it is, y'all. Our answers: mean 52.3, 53 is our median, 51 and 58 both are modes because they were both twice. My mean here is 19, my median is 20, and my mode is 24 because it was there 3 times. It was the most. So that's how you find your measures of central tendency. The next thing, and again, this is all calculator, you don't have to use this formula. I'm not going to ask you guys to understand or to memorize that. But let me tell you what measures of variation is. Measures of variation is a value that describes how spread out a set of data is. Okay, so another way of understanding this is it's called measures of dispersion. So real quick, before I even show you these, let me just explain why you need to know variation. Sometimes it's good to know the averages, like we have up here, but sometimes it's good to know how tight your data is. If your data is real tight, you can really have confidence in what that data is telling you. But if it's really, really spread out, you can't really trust it as much. So one of the statistical measures that's very important is variation, okay? How dispersed your values are. So like I said, we are not going to learn how to do this with, this is still going to be used in a calculator, but we're not going to learn the formula for this. Instead, we're going to utilize our calculator to find it. And we start with standard deviation. Now, I know I'm skipping variance, but that's okay. I'll come back to it. Standard deviation is a value that our calculator gives, and here you see it right there, okay? That is our symbol for standard deviation. Now, what standard deviation is, it is the square root of the variance. So if I was using my brain, I would find the variance first, and then I would take the square root of it, and that's my standard deviation. But standard deviation is the one that we would call the most useful measure of dispersion. Okay? Now, why did I skip variance? Because our calculator actually, in that one var stats, it gives me my standard deviation. So if standard deviation is the square root of the variance, all I have to do to then find the variance is simply square that standard deviation. So we can do that with our calculator, even though it's not going to be in the one var stats when we run it. So our variance, if you want to put this defined, it's the average squared distance of each value to the mean. So basically, guys, what standard deviation is doing, standard deviation is telling us how far on average our values are away from the center of your data. So like I said a minute ago, the lower the standard deviation, it indicates that your values are closer together. And in math and in statistics, we really like that. We want our values to be really close. The higher the standard deviation, it tells me that the values are more spread apart. For example, if I'm given a test, obviously I'm going to grade that test and I'm going to assign a grade to all those tests, and I'm going to look at the average. So let's say this class made a 75.3 average. Well, I want my standard deviation to be really tight. Why? Well, I don't want someone to make 100 and someone to make a 30. I want that average to exist because about everybody was doing close to the same. Now that doesn't happen. So when I give a test, a lot of times we have people who did really poorly, but then I have people who did really good. So we want the opposite. Now, this takes you to your calculator steps, but I'm going to show it to you right now. We're going to use our calculator to find the standard deviation, and then we're going to use our calculator, but not the one var stats, to find the variance. So let me show you. Let's do number 5, and we'll do number 7, and then we'll call it a day. So I'm going to go back to stat edit. Actually, you know what? I'm going to reset my calculator. 2nd plus 712, because the last time I put a lot of numbers on there. I'm going to go back to stat edit now, and I'm going to enter these values. I got 85, I got 88, I got 91, 96, and 100. So I'm going to hit stat, go over to calculate, and I'm going to run a one var stat. In this case, so I'm not worried about the X bar. I'm not worried about the average. I'm worried about standard deviation. There it is. Standard deviation. And usually we round standard deviation to 2 decimals. So my standard deviation is 5.40. 5.40. So go back with me to my paper. Look, standard deviation is 5.40. But variance is taking that value and doing what to it? Squaring it. So we just go back to our home screen and we do 5.40 squared. And that is my variance, 29.16. Okay? So that's literally all there is to it. Your calculator literally finds a standard deviation, and then we use that to square it and find our variance. So it doesn't matter which one I do. I said I'd do number 7. Let's do number 8. It's got several more numbers. I'm going to reset my calculator real quick. Never a bad idea. Go to stat edit, and let's enter them. Give me some time. Let's do it. We got 127, 81, 135, We've got 100, 97. We've got 115, 72. We've got 152. We got 63. Can you tell? It looks like our standard deviation is going to be pretty high on this, because see how spread out the numbers are? They're not real close. They're not real tight. Last one's 164. Whoops, not the negative. 164. All right, here they are. I'm going to go stat, calculate, run a 1var stats, and again, we're looking for standard deviation. There it is, 32.22. 32.22 is our standard deviation. There it is. Now, how do I find my variance? I literally take that value, 32.22, and I square it. My variance is 1,038.13. And that's it. That's how you find mean, median. That's how you find standard deviation, and then in turn, variance. Mode is the only one you have to really think about. So it's the most repeated value. So very, very simple. I hope you guys realize that this video is only about 27 minutes long. So you actually have some time to do your homework. So go past this data distribution note sheet in your packet, and you're going to see it right here. It says measures of center, variation, and normal distribution. We're only doing the front side. We're only doing 1 through 6 tonight. And I want you to ignore the MAD, okay? Ignore the MAD. You're not doing that, but you're doing all the other values, okay? You're finding mean, median, and mode of these two. You're finding standard deviation and variance for these 4. That's your assignment. I expect this to be done when we check this. Honestly, it'll probably be on Friday, because Thursday second period is at the little thing. So this will probably be gone over on Friday, okay? I'll see you tomorrow.